This is an example of the node voltage method. In this example, it is desirous to find V1, which is here, as a voltage across the 250 ohm, and I2, which is the current through the 7.5K resistor. In order to do this, first a reference point needs to be placed. So the reference point is always placed in the location where the most branches are connected, which would be here. And I place this reference point with this symbol as 0 volts. I can then label the other node locations. V1's already picked here, so I'm going to call this one V3 on the top and V2 at this location. The next step is to find a node voltage equation for each node. I'm going to first start at V3. I therefore want to write a current equation going in this direction for this one. And I'm going to put this arrow down and these two arrows across here. And I2 is already placed there. So the equations for each of these, I2 is going to be the voltage drop across this. This is all one connection. And it also goes all the way around here till you don't have any more elements. So the first place you get to an element, that's the whole connection. So this current I2 is going to be V2 over V2 minus 0 over 7.5K. The current here going in this branch is going to be V2 minus 0 over 1.5K. I always start at the positive side of the arrow and move to the negative side. So on this positive side, I have V2 The current going through this resistor of 250K is going to be, I start at the top and I subtract off anything on the negative side of the arrow. So V3 minus, and then this is the drop from V2 to ground, so V2 over 250 ohms. And then the current through this one is going to be V3 minus 1.8 minus 0 over 300. So now I'm going to do a current summation at each of the nodes for these currents. So at V3, I have a minus 4, a plus this current, and a plus this current. So that gives me a minus 4 milli. And then it's a positive V3 minus 1.8. That's just 8 volts over 300 ohms plus a V3 minus V2 over 250 ohms equals to 0. Then I'm going to do a current summation here at V2. I have a negative of this current, a positive of this current, and a positive of this current. So I get a negative V3 minus V2 all over 250. And then a plus V2 over 1.5K. And then a plus V2 over 7.5K. And that equals 0. So I have these two equations with V2 and V3 are my unknowns. So I can solve this for V2 and V3. Once I get V2 and V3, I can solve V1, which is V3 minus V2. So V1 is going to be V3 minus V2. Then to solve for I2, I have V2 over 7.5K. So once I find V2 from these equations, I can also solve for I2. So now to solve for these, I need to put one of the terms in terms of the other, so V2 in terms of V3, and then plug that into this equation here.